Hello everyone. I want to solve this interesting question looking at two charges placed in a plane or in a coordinate system. Now, let's see, a charge of 2 microcoulombs is placed at 0.75 centimeter and another charge of plus 3 microcoulombs is placed at 100,0 centimeter coordinate. Find the electrostatic force each exerted on the other in terms of their coordinate system of what? In free space. In terms of their coordinate system in free space. So now let's start to analyze the question right away. Now follow me. A charge of minus 2 microcoulomb is x and y. So this is y coordinate, y and x. Now for y, that means x is 0. Now don't forget x is 0 along the y coordinate and y is 0 along the x coordinate. So for us to place minus 2 at this point, so what does that mean? It means x is 0, y is 75. Let's locate that point here. That means from here to here is 75 centimeters. Because this is the origin. You are measuring from here. So this minus 2 microcoulomb. Then another charge of plus 3 microcoulomb is placed at x 100 and y what? 0. That is should be found along this side. Let's see here. So here is what? 100 centimeter. So y is 0 here. So this is what? Plus 3 microcoulomb. Okay. Find the what? Electrostatic force each exerted on the other in terms of their coordinate system. Now let's draw the line of action connecting the two of them. Now having done that, now this is one charge and this is the other. Now they will attract each other. This one will apply an attraction force, let's say F. Then this one will also apply an attraction force, which is also F. So what is the distance from this place to this place first? The distance here. What is the distance? We can use Pythagoras theorem by saying, let's call this one point A, point B, and here is what? 0. So we said what? AO square plus what? AO square plus BO square is equals to what? AB square. Pythagoras theorem. So here is 75. This is AO. 75 centimeter, or just leave it in centimeter square, plus what? 100 square is equal to what? AB square. So how do we get that? So I want to say AB is equal to square root of what? 75 square plus what? 100 square. So what do we have? 75 square plus 100 square. 75 square plus 100 what? Square. Then square root will give us 125. So 125 cm. So that means AB is 125 cm. Now, having understand that, let's say this one incline at an angle to this vertical theta, and let this one make an angle of alpha. Now, if we want to now solve for, don't forget, the force of A is this, while the force of B is this. The force of B on this charge is this one. So this one is B on A, while this one is what? A on B. So this force, now who created it? This one. This force, who caused this force, is this. So take note of that. But we have to calculate the what? Each of them. Now, let's see. FB. Now, That means F at B now. The force at B, electrostatic force at point B. What do we do now? Look at the board. Now let's resolve this F into horizontal and vertical, knowing where this is vertical and this is what? Horizontal. So this is plus y and this minus x. So if I resolve this one now, this force, if I resolve it to the horizontal, it comes what? Like this. So negative what? So that means the force at B is equal to what? F what? Cos what? Minus. Why is it minus? Because this is along the x-axis, is negative x-axis. Cos alpha I plus, then is going up. So that is what? F plus F sine alpha j. I is x-axis, coordinate unit vector of x-axis. J is unit vector of y-axis. So minus, because it's, if you look at the arrow, when you resolve it, it's going towards the negative what? Direction. When you resolve it upward, it's going to the positive direction. You can as well say A on B, the electrostatic force of A on B. So that is it. A on B is what we are calculating. Now, what about electrostatic force of B on A? So B on A is this one now, which will now be equal to, if I want to resolve this one, now this is negative y-axis, and this is what? Positive x-axis. So if I should resolve it, look at it. If I resolve it like this, this is the black marker head is what? Going down. But if I take it like this, it's going towards a positive direction. So that is just that. Let me clean this. Let me this. So in this case now, so we are going to have it as what? Negative, positive x, f, what? It's going to be sine. Don't forget the angle is resting on the vertical in this case. This one, the angle is resting on the horizontal. That's why the horizontal take cos. But now in this case, the angle is resting on the vertical. So this horizontal will take sine here. Sine theta plus, that means I, unit vector to show direction. Then it's going negative what? Y direction. So minus F what? Cos theta J. Why is it cos theta? Because it's what? The angle is actually resting on the vertical. So you can only close it with cos and open it wide with sine. So when you are opening it wide, the angle wide, you are opening towards the x-axis. That's why it's sine. When you are closing, you want to close this angle, you close with cos towards the y-axis. So y is what? And it's in the negative direction. That's why this one is minus sign here. So why this one is in positive? That's why if you resolve it, you are going to have plus here. So this is the actual resolution of the force of each other. But how do we get this one? How do we get it? Now, very easy. Now, cos alpha force. What is cos alpha? Cos alpha is what? Adjacent over what? Hypotenuse. Adjacent over hypotenuse. So that means that goes what? 100 what? Over 125. That is cos alpha. Then what about what? Sine alpha. Sine alpha is what? Sine alpha is what? Opposite over what? Hypotenuse. Hypotenuse is opposite to this, is 75. You can see it. It's opposite to this angle, then this is hypotenuse. So this one is 75 over what? 125. So what about cos theta? Cos theta now is equal to, what is cos theta? Looking at this theta here, here becomes what? Adjacent to this theta. Here is adjacent to this theta. Why here is hypotenuse? So this is adjacent. So now what? 75 over what? 125. Now, what about sine theta? Sine theta is what? Opposite to this theta. The reference angle theta is the opposite now. This 100. So we say 100 divided by what? What is the hypotenuse there? Oh no, opposite of hypotenuse. So at one, we use what? 125. Now, I haven't done that now. Simply just substitute the value inside the angle without wasting your time. Now, but remember our force, we don't know the force yet. So let us find the force, because F, whether this or this, for every action there is equal and opposite reaction. So this, let's say this is Q1, and this, let's say this one is what? Q2. Q2. So we are going to use KQ1 Q2 over R squared. We use the R is the distance between them, between the two charges, which is of course 125 centimeter. You can convert to meter when you want to use it. So let's go ahead. Don't forget our K remains what? 9 times 10 to the power what? 9 what? Newton meter square per column square. That is our K. Now, what do we do? Let's put in our value. Define our F. So our F now becomes what? 9 times 10 is power 9. Absolute of what? Minus 2 times 10 is power minus 6. Then we are going to have what? Then 3 times 10 is power minus 6. Absolute of that one. Divide by what? What the distance? The distance will now be equal to what? Divide this one 125. The R is 125. If you don't know it now. R is what? 125 cm. So you convert it to meter, divided by 100. So if you divide by 100, you are going to have 1.25 all square. Now, after having done that, let's pick up our calculator and see what we are going to do there. So we are going to have 9 times 10 to the power what? Let me just multiply 9 times 64. Then divide by 1.2, 1.25 all square. So this will give us what? 34. Then let us what? Do our what? Okay, let me use it like this 3 times. Okay. Times 3 times 10 per what? There's something I want to confirm so that I will not make mistake. So this one will give us what? 0. What? 034 what? 56 Newton. So that's what I want to have. 0.03456. So that is the answer to that question for that force. Now, I haven't noted that because why we take absolute, we don't want to allow what the minus sign to come out of the word, because we already taking our minus sign from the unit vector. So unit vector will tell us the sign and the resolution direction will tell us the sign. So no need to bring out force here. So with this one, we're going to solve magnitude for us according to the Coulomb's law. Now, let us place D there accordingly. Now, F A on B, that means the force, electrostatic force of A on B will now be minus what? 0.03456. What is cos alpha? Cos alpha is what? 100 over what? 100 over 125 I plus what? 0.3456. Then again, sine alpha is 75 over 125. J is I. So what do we have? You press your calculator now, then times 100, then divide by 125. That will give us what? The force will give us minus 0.027648 I plus what? Let us also do that. 0.03456 times what? 75 divide by what? 125. So that will give us 0. What? 020736 J. So this is the force of what? A on B. What about B on A? On A, the force of this B on A. So that will now be this. I want to have our what again? 0. What plus now this 0.03456 open bracket. What is sine theta? Sine theta is what? 100. Don't forget. See, you are looking at this one now. The one we have solved for is what? This. So they are what? 100 over 125 plus what? What about the next one? I. Let's put I there. Then second one is what? 0.03456. Then multiply by what? What is cos theta? Is 75 over 125 J. So we also will press our calculator to get 0.03456 times 100. I think they are going to give us the same thing. No need to do it, but now 0.027648 I. The same thing here, just repeat it here. Plus what? Same thing also 0.0. This one will now be minus. I think I did not put minus here. There's minus here. Thank you. Okay. This is minus. So 0.0 minus 0.020736 J. Now this is force of what? B on A, and the force of A on B. Now if you check critically well, you will notice that they have the same magnitude here, but opposite direction. The same magnitude here, opposite direction. It means that these two forces are equal but opposite in direction. That means what? The first, this is the answer to the question. These two. This first one and this second one. So, but the force of what? Force of A on B and what? And force of what? B on A obeys what? Newton's what? Third law of motion. Newton's third law of what? Third law. For every action, there is equal and opposite reaction. That's what we have been able to bring out from this particular question. You must understand that the two of them exert equal forces, but in opposite directions. As you can see, the one at A, the one that A exerted, one is one at B that is exerted by A, which is this one. This is force. The coordinate system, because they say we should find what? Say, find the electrostatic force, each exerted on what? On the other in terms of what? The coordinate system in free space. In free space, that's why we do not involve dielectric material when we're using this formula, because we assume it what? It occurs in air. So if you check, they are the same but opposite. The same but opposite. So, and what you are seeing here, they are also the same but what? Opposite. So thank you very much for watching. Have a nice day. Thank you.